Whoops. No, I clicked too early. We forgot to say the welcome bit. You just can't get people who can operate technology these days. Right. Welcome to Quarkus Insights 195, and we're going to be talking about complementing LLM with agentic AI in Quarkus with Mario and Daniele.
There you go.
I've got latency as well.
Yes.
We're just disastrous. Hello, welcome. What's happening is when I push a button in the UI, there's like a latency of several seconds before it actually works, which means I then push a different button because I thought I did it wrong, and so it's all going wrong. And the moral of the story is never change your UI, or have internet, or use computers. And with that,
okay,
we can.
Okay, I all thank you for attending this session. Daniel and me are about to talk about some point of view on how to do effective artificial intelligence with Quarkus and its extensions. So my name is Mario Fusco, and I'm the principal software engineer in EDET, and I'm the project lead of Drools and a contributor of Quarkus, and also one of the main contributors on Langchain4j this day. Daniele, do you want to introduce yourself?
Sure. Hi, I'm Daniele. I work with Mario in Red Hat, but more specifically in the AI engineering area, so on OpenShift AI. And I focus on the serving capabilities. So everything that you need when you need to serve a model, generative AI model, but even predictive AI model.
Okay, so let's start with our presentation. Of course, feel free to ask questions if you have any. So what this is about? The main idea behind this presentation is to explain why LLM and machine learning alone are in many cases not sufficient. Okay, so if you think about it, what is machine learning? Machine learning is a set of statistical algorithm, a statistic method to find correlation between, let's say, generically objects. Okay, and this works pretty well. Unless when it doesn't, which means that often it happens that it doesn't know about the proper business domain. So this is what happened to me a few months ago. I bought a washing machine on Amazon, and of course the day after I've been suggested to be 3 more of them, just because probably Amazon decided that I was to create a new laundry, or just in reality, just because, you know, these things are statistically correlated. So it is normal that
you can never have too many washing machines.
That's a good point. Yes, but in reality, yes. If you know,
actually, yeah. You mean you don't have 5 washing machines, Mario? I'm worried about your hygiene now.
Okay, probably Amazon knows about this, but in normal life, I believe that people is not going to buy 3 new washing machine the week after that he has bought one, and this is you know this by apply, well, just common sense in this case, but in general by applying the business domain, the knowledge of the business domain, which of course Amazon doesn't have in this case. Okay, and Daniela, do you want to clarify maybe the difference of the terminology? Yes.
Yeah, let's say part of the confusion, part also of the challenge when we approach artificial intelligence is that there are different definitions, and sometimes we sort of overfit from a specific meaning that is the one that is more fancy at this stage. So historically, artificial intelligence collect literally everything that like every algorithm, every techniques for that the computer can do to imitate let's say human intellect and behavior. So machine learning is more specific about statistical algorithm, and deep learning it's about neural network. This is a quite already traditional type of classification, but if we are now also open, let's say, including the conversation, large language model and generative AI, Mario, can you go next to the work?
Sure.
If we look at, let's say, the diagram, and the Venn diagram is because sort of impossible to read, because in reality, generative AI is not really a formal term, a formal definition. It includes a transformer-based model, that it's what we usually mean with a large language model, but there are also other type of techniques that are part of the generative AI ecosystem. So if you see here, the Venn diagram becomes a sort of many-to-many type of overlap. So even the definition of generative AI, this one is coming from Wikipedia, is like it's a subset of AI that use generative model to produce text, image, video, or other formats of data. So even the definition is some sort not really tied to what, I mean, generative because it generates something, okay, but not really focus on the algorithm that is using for that. So if you're looking about a transformer-based model, that is what we usually use in those days under the class of large language model. Mario, can you go to the next slide?
Sure.
A very, let's say, simple, this is not really very detailed, but very high-level introduction. This is all coming from an initial research done in 2017, as far as I remember, from Google. The paper was Attention is All You Need. So the whole concept is like that. When I needed to produce a text, so large language model predict the next token given a specific text, and this prediction, this generation happened multiple times until the whole sentence or the whole output is produced. And the concept of attention is like that. I have an attention weight vector that let's say put more emphasis on some of the words, and this is also how human overall interact, because we say a lot of different terms, but we pay more attention to some of them that are critical about the context. And this algorithm try to mimic essentially this behavior. And this is like, let's say, the core idea in the transformer architecture. Then there are a lot of optimization, a lot of implementation, but just to give you, let's say, a very high level understanding about, okay, what we mean with, let's say, attention.
Okay, and as Daniele was saying, naming and definition are important, but sometimes they are also confusing, or they change with no, in all honesty, no better reason than marketing. For instance, in the 80s, we had this cool thing called the rule engine. Then at some point around the 2000, the rule engines was not cool anymore. So we started calling them production system, and they became cool again. And of course, we don't like production system nowadays. It's all about artificial intelligence. And so now we call them symbolic artificial intelligence. But in reality, it's the old 40 years old technology that is still useful also now. So don't be fooled by name. Okay. And this trend is also reflected in some report of the new emerging technology. So you can see that it's the workflow and decision automation platform. It's for early adopter in this InfoQ report, but in reality, these are just automatic decision than rules, right? And in the same way, if you think about it, if you write policy as code, it's a specific application of a rule engine, of a business rule. You use the policies are also used, so it's trivial to encode them in a rule-based way. And on the other side, the introduction of this machine learning algorithm also created a few specific problem. The most obvious probably is the one about the accountability of the lack of it. I mean, if something goes wrong, who is responsible? Think about a driverless car, and if you have an accident, who is responsible for the accident? The driver, the car manufacturer, the provider of the artificial intelligence algorithm. It's a very gray area at the moment. Okay, and this is also caused and related with the fact that these systems are usually not very transparent. It's very hard to track how a decision is taken, but you need often to track a decision, to audit a decision, also for legal reason. I mean, if you ask a mortgage to your bank and the bank refuses it, the bank cannot tell you, look, you cannot have your mortgage just because the computer say no, just because the machine say no. I believe they have to provide more, let's say, human, understandable, and acceptable explanation than just machine said no. And the third category of issue, to me, as an engineer, probably is the most interesting one, because the introduction of this system also introduced a new category of malfunctionings that I cannot classify as a bug in reality. I mean, to me, a bug is that, I have an if condition, and then in that if condition, I used an and instead of an or, and my program misbehaved because of that, and I break my head on it. I spend the whole night to figure out where the problem is. I finally found the mistake. I fix the bug, turning the end condition into an or, and I compile, package, and deploy my fix, and I'm done. Okay, so there's a bug that I in some way track and understand and fix, and that's all. But this is not the case with this generative AI system. If they have an hallucination, there is no one point where you can investigate what's going on and see the problem and fix it. It doesn't work like this. Hallucinations are part of how these things work.
Yeah, we've got a question about that sort of that probabilistic nature of the systems, which I think is perhaps maybe one for Daniele. Samarit asks, fundamentally, LLMs still are predicting next token on conditional probability using previous input token information. So is that a good description?
Yes, but with the addition that those models being trained with like every possible text that you can imagine. So this kind of knowledge is, let's say, it's the synthetic, let's say, it's what has been trained during the huge training phase. So those models are pretty good about predicting. So they are using the context to just understand what the user wants and predict the actual token. But the vast majority of the knowledge that they're bringing, so it's really about the amount of data that they were able to process. So the final algorithm, the final input is not, you cannot think about like a function that is like, given a text, it's able to produce the next token. Yes, this is what it does, but this is based on the fact that it brings in like Wikipedia and every other possible source that you can imagine. So they're very, very good at producing text that at least sound very natural for a human being. So yeah, I think that the definition it's correct. It's just that those models are getting very, very way more powerful and way bigger.
Okay, yes.
Makes sense. Thank you.
Thank you, Daniele. And yes, I was saying that, just to recap, if you have a problem with an LLM, it's not something that you can go and fix by fixing a bug in the code. And this also raises some question. For instance, now I'm working on Langchain4j, as I said, and one of the problem we are facing and discussing now is that from time to time the LLM asks for the execution of a tool that in reality doesn't exist. And what you do in that case? You cannot propagate the error to the user because they don't know nothing about this. You probably have to invoke a tool, but you don't know which one. I mean, it's more, philosophical than a technical problem or a user experience problem also. And of course, this kind of problem are very peculiar, are very typical of the system and doesn't exist in a completely deterministic system. So let's say, to recap, why we want to mix machine learning and symbolic reasoning, because machine learning is amazing, is super useful, and through it you can find statistical correlation and maybe discover new pattern, a new relation between your data that you were not aware of. Okay, but on the other side, you already have clearly encoded, clear in mind, or probably better formalized the rule of your business. And if so, probably you don't want to have them rediscovered from scratch by machine learning in a more expensive and less reliable way. You just want to encode those business rules and make them part of your system together with the machine learning part. Okay, so we have this situation that corresponds to what Daniele was explaining before, but the business domain logic knowledge is encoded in the rule engine part. And so far I spoke about generative and predictive AI as two interchangeable and similar way. They are, of course, two distinct things. I don't want to go through this table, but I put it here just for reference. The main difference is that with generative AI, you generate again text or images or videos even completely from nowhere and just starting from the user prompt. While with predictive AI, you try to produce a result, but based on the data, on the provided data, based on the statistical data that you provided for training. And as I said, it's the trying to mix rule engine and machine learning it's a sort of well-established research area. In research, this thing is called neurosymbolic AI. Probably I prefer the term hybrid AI, but they are the same thing. And there are a few patterns of how to integrate this technology. The name of this pattern are very, very questionable in my opinion. I cannot understand what they are doing just reading the name. They don't make much sense to me. But if you read the description, probably they makes much more sense. And today we will see an example of the latest of the pattern that are listed here. So using a rule engine to hide a customer-facing chatbot. Okay, and this demo, this chatbot has been inspired by news that I read a few months ago. I don't know if you heard about this, but in essence, what happened is that Canada had this chatbot used by customer, and customer was indeed chatting with it, and this chatbot at some point totally hallucinated and suggested to the customer that he was entitled to receive a refund of 650 Canadian dollars, which again was an hallucination. It was totally undue, but of course then the customer asked to have that refund. and of course the company said no, this is not part of our policy. So the customer took a screenshot of the chat, went in a court in front of the judge, and he had right. Air Canada was forced to pay this refund, and of course the day after, the chatbot was shut down, totally disappeared, of course. Okay, so this is the kind of embarrassing situation that you can face if you give your business entirely in the end of something that could have hallucination. And yeah, Daniele, maybe you want to clarify in more detail what these hallucinations are and what are the possible solutions.
The problem that Mario is mentioning, it's some sort of part of the nature of similar models. So given the complexity and also how powerful and flexible they are, there is this kind of, let's say, aspect. And this is a quote, for example, from Google CEO that there is like no real solution to making sure that a similar model is not going to provide a model information that is incorrect. So it's not something that is like, well, it's a bug, so we need to fix it. It's a bit in the nature of a similar system. So if you go, Mario, to the next slide.
Before you do, we've got a question about the Air Canada case, which I think sort of relates to the slide that we were just looking at as well, about the no solution. So Bridget asks, did they use RAG for the chatbot, and would RAG have fixed the problem?
Yeah, this specific implementation from this airline was most likely just like a sort of proxy of OpenAI, and it was like a few times ago. So probably there was not really advance in try to mitigate this challenge. So now essentially RAG and many other techniques try to making sure or try to enforce the model to stay within some boundaries. So yes, the usage of RAG is one of the most common patterns, for example, to making sure that the model only uses a set of information that I want the model to use. But still, this doesn't really solve entirely the problem, because even in a similar scenario, the model might produce something that is incorrect.
I believe that looking at the code of a demo, it will be clear that that our solution is much more reliable than RAG. Yes.
Yeah, and let's say we are sort of spoiling a bit of the rest of the presentation, but the whole, it's even in the title. So the whole idea of agentic AI, it's like the composition of different to try to create a powerful AI system, preserving, let's say, the control, or trying to mitigate the risk. That is what we also do for software development, because like, can you write a code that has no bug? Well, no, but I can try to put in place some techniques and some sort of due diligence to mitigate the risk, the blast radius. And even when you apply these to AI engineering, so the usage of AI, let's say LLM in particular, together with software to build your solution, you should have the type of guardrailing to, let's say, keep everything on track. So here, this, for example, is a quote from Red Hat Research Quarterly. So this was like let's say, specific article about generative AI, and we are hiding here that hallucinate output, and we're mentioning as other solution the possibility to integrate other methods like knowledge graph, symbolic method, together with large language model, so that let's say we can try to mitigate more and more the risk, or that there is still also some let's say research direction or like research field that they let's say can that should be at a certain point maybe solved, or this is going to remain. So it's still an open problem essentially. So, and if you go to the next slide, so there are even research publication around this topic, and they are claiming that it's like in the nature of similar model to have a similar behavior. So that doesn't mean that we cannot do anything, but it's a bit of let's say part of how LLM works. They always give you the most let's say probable next token. So if you look from an hallucination perspective, in general, a quite generic and high-level way to define what is an hallucination is an inconsistency, and there are different types of them. So some of them could be like within the output itself. So the output that has been produced not coherent within the output itself. Like Daniele is told to see the shorter person, or like between the input and output. So I'm asking something and the model is producing something completely different. I ask the model to use a formal language, and the output is a reality more like colloquial, or could be even factually wrong. So if you are asking a model, an LLM, to extract knowledge, like when the first person went to the moon, and it's like, well, the first man went to the moon on the 2024. So that is, I would say, the worst case scenario. So it's really like there is a topic that I'm not aware of, so there is something that I don't know. I ask the model to produce this kind of content, like to when I ask something on internet. So I wanted to extract an information. It's the worst case scenario because it's how can I verify? How can I judge? So, for example, for the first scenario, even if I just look at the sentence, I might be able to detect that there is a problem because I realize that it's not consistent. Even for the second one, given that I can try to understand, do I consider that, let's say, formal, the output or not? But in the third scenario, I'm literally asking the model something that I don't know. And how can I judge the model? How can I judge the result? So if we look, let's now look at a bit more like, okay, why this is happening? So we say that LLM is a black box overall. So it's a very, very complex neural network that has this the possibility to hallucinate. So of course, like there are different reasons. Some of them, I will say most of them in reality are not completely under our control. Like the first one is like, okay, if in the training set, let's think about the first question, the question about the man on the moon. If in the training set this information was not there, of course, the model is going to give you what is more likely or what seems to be a right answer, but it doesn't really know. So part of it is that we should have literally every possible information in a training set. And of course, first of all, this is something that is impossible by design. And at the same time, we don't really train those models. This is usually done by few very big companies, even if there are now a lot of research even to make cheaper and more, let's say, more applicable the training of those models. It's still something that, even if, let's say, that is not just an hardware constraint, it's a really complex job. The second one is that the generation nature of a similar model, we want the model to, let's say, be creative. So we needed to have creativity because we want to use those models maybe to generate, I'm asking like, can you generate an abstract for a conference considering those information? So I want the model to explore, let's say, a bit in the spaces to give an output that is not maybe the most common one, because I don't want it to produce every possible abstract in a very formal way. I want it to be creative. And there are parameters to use that, like temperature, top K, top P. So I can guide a bit the model to be more or less creative, but at the same time, again, if I reduce all of that and say like, always give me, because creativity from this kind of model means don't give me always the most probable token, but explore also some other path. So don't just give me the one that you think that is the most probable, because otherwise, more likely you are going always to produce the same type or similar type of answer. And the last, we have, let's say, most of the control, because the more we are specific, the more specific is the input, not just in terms of query, but also in terms of context. Like, again, I want an abstract to be produced for a conference that is about backend development, where the session need to be no more than 40 minutes, where I should explain what I'm. So the more I can add in the context, more likely the model is going to produce quality, let's say, high quality result. So at the certain point, you can say like, okay, why I cannot just like try to fix LLM hallucination, just use another LLM that from a certain perspective, it's not too far from like in the past there was like XML, and there was this famous quote to say like, well, XML, it's like violence. If it doesn't work, you need to use more. So you want the LLM by itself doesn't solve the problem. Okay, let's add more LLM. In reality, there is a whole pattern that is called LLM-as-a-judge. Mario, can you go to the, okay. That in reality, it sounds a bit strange overall to say like, okay, I want to use another LLM to judge what I'm writing. But the reality is that you can do that especially if you wanted to validate the output. So I'm not asking the model, do you think that what has been produced is correct by itself? Because especially if I'm using the same LLM, more likely it's going to provide the same answer. But I can have, if my original question, for example, was about the tone or like the style, I can say like, okay, do you think that this output, sending the output, is using formal language? Or if it's, I expect that the output has like some sort of positive, let's say that I'm creating a chatbot for my company. I always want the chatbot to be like kind with the user and having always positive type of writing, not to try to be, even if the user asks multiple times the same question. So I want to apply some sentiment analysis, so I can take the output and say like, okay, can you judge if the text has a positive sentiment or not? So I'm still using LLM in reality to do some sort of analysis, but at the same time, I'm changing the question. So I'm trying to ask a very specific question to try to validate the output. It doesn't work for factual checking because, again, if I'm asking the model some knowledge that I don't have, even if I ask, okay, can you double check if like really the first person in the moon was on 2024? Okay, that I don't have any way to get this additional, let's say, information. So this is those are techniques just to try to mitigate the problem without really adding anything to the picture, just using purely LLM. But let's introduce agentic AI. So there are like there is some sort of expectation that we take data in whatever form and we add machine learning and everything is perfect. Now, of course, even if we generalize whatever we do, it's artificial intelligence. Then we go to generative AI. So it's a wonderful world where we ask stuff and this is going to produce unicorn or stuff like that. And then we go to agentic AI that start to produce completely arbitrary and not really control the situation, where it's like, okay, could be good, could be bad, could be worse, and we don't really know because we're just adding more noise.
You're winning the best illustration ever.
Actually, this is from, I think, a tweet, or I don't remember, Mario.
Yeah, well, I found somewhere on LinkedIn, and I pinged Daniel and said, okay, we need to use this thing.
Yeah, it's a very nice introduction to agentic AI, because from a certain perspective, it's also true. I mean, you are making the system more and more complex. And if you don't know what you're doing and you don't really do, let's say, apply your due diligence, you risk that at that point, you're just like really having an order of magnitude more of complexity and problem more than an actual solution.
Yeah. Going back to the question of using a judge, does it make a difference in terms of the results if you use the same LLM or a different LLM?
In general, yes. And one of the topics, there are now more and more LLM that has been fine-tuned for specific type of task. So just to give you an example that we also maybe we can touch a bit later. Let's say that I want to avoid my model to provide violent answer, or like that is able to produce, that is able to even get personal information or similar. There are models like, for example, there is Granite Guardian or Llama Guard that are the same base model, but has been fine-tuned specifically to try to detect similar pattern. So if I wanted to take an input and ask this model, do you think that this has some, I don't know, do you think that this contains personal information? Or do you think that this has, let's say, hate speech type of content? So do you want to classify, do you think that there is a risk, an implicit risk, a safety risk related to this question? Technically speaking, you're probably using maybe behind the scene, let's say, the same base model, but in a version that has been fine-tuned. That means has been customized to be specialized for similar tasks. So in general, the suggestion is that there are, again, to look at, if you want to apply an LLM-as-a-judge scenario, to look at the model that has been fine-tuned or specialized for the type of check that you want to do. For a traditional sanity check, like, okay, again, is this I ask it to produce a formal content. I want to verify that the output, do you think that the output is using formal language or not? You can even use the same LLM. But again, for considering the type of analysis, the type of challenge, the type of question that you can raise, more likely you wanted to look for a very specialized LLM. Okay. So let's do a bit more formal, I would say, introduction to agentic AI. So an agentic AI system, it's a system that is designed to use models, so LLM, data, tool. So it's not just, I think that the real outcome of all these initial steps was like, okay, taking an LLM, a single LLM, ask a query to say like, give me something, and trust that as the only end-to-end need everything that I needed to get the result. Of course, it's not enough. So I probably need to enrich this. How can I enrich that? Well, again, data, more context, tooling, like a specific function that can help me. So a tool is nothing else than from an LLM perspective, like a function that I register in the query itself to say like, be aware that I have a tool that can be used to validate user age. So the model is aware that if the user is asking, given this person, do you know if the age is valid or not? The LLM automatically realizes that I have a tool for that and is going to use this tool. At the same time, at that point, those models can be used also to do some more advanced reasoning. So they can do some planning. So they can decide, given a goal, like, okay, please verify the policy, or making sure that something happened in the right way or not, to understand, given the task, given the tool, how many steps. So what are the steps that I need to do? With the goal to minimize human, let's say, interaction, so that this system should be automatically able to combine and, let's say, compose all this kind of capability, so that at that point you are trying to get the best of all the different, let's say, capability tool techniques that I have. So I have a traditional type of orchestration, but also existing services, even symbolic AI, but preserving the fact that an LLM, it's very good at understand what the user is looking for and, let's say, generate an answer that is matching that specific request. So if we wanted to try to, next slide, Mario. If we wanted to try to, let's say, have a single picture to describe, like, okay, how an agentic AI system, like a complex one, can look like, there are this kind of patterns that are emerging. So you have an AI agent that is able to perform action, but also has memory, so is able to retrieve information that has been maybe said previously. It has tool integration, so like calendar, calculator, so I know that if I need to do some analysis, I don't need to just guess by myself, because otherwise NLM is going to guess by automatically, like, okay, this is I needed to find the delta between two dates. I can try to guess, because LLM at the end are going to give you the most probable answer. But if I realize that I have a tool that is designed for that, I can use that. At the same time, there are, again, in the planning space, there are different pattern techniques that I can apply to be, again, reflection. That means, again, I use an LLM to validate something. So I try to reflect about what I'm doing, chain of thought. So it's a very big field. But now I think that we are ready to start with, let's say, the demo and the use case. So Mario, do you want to continue?
Yes, before
sorry, Mario. Before you go on, would the tools always be deterministic, or does that depend on the tool?
To answer this question. So no, they are not for a twofold reason. First of all, I was saying a few minutes ago about the problem that we have with Langchain4j. So the invocation of the tools is not deterministic, because deciding that you need to use a tool and which one is up to the LLM, and that thing could be not deterministic. The LLM could use the wrong tool, or decide to ask to use a tool that doesn't exist at all, or decide that it doesn't need a tool when actually it should use one. So this is the first problem. The second problem is that a tool could be basically anything. It could be a rule engine, as in my case, and in that case, yes, it's deterministic. It could be a simple Java method doing something, and in that case, yes, it is deterministic. But the tool could be another LLM, as in the LLM-as-a-judge pattern, for instance. And in that case, you go back to the problem, to the indeterminism of the LLM. So in essence, the problem is that you use a tool that is not deterministic, because even the tool is using an LLM internally. Okay, I hope this answer the question. So now let's give a look at the demo. As anticipated, this demo has been inspired by that problem of the Air Canada chatbot that I mentioned before. So my solution here is to use an LLM for having a chatbot that can interact with the user in a user-friendly way, as usual. But when it's time to calculate the eventual refund, to figure out if a user can have a refund and what's the amount of this refund, then I want to be sure that I'm going to apply the airline proper policy. I don't want the LLM to hallucinate. I want to encode this policy into a rule engine and make rules to evaluate the refund application. And in reality, I'm using Drools for a twofold reason in this demo. The first, again, is calculating the refund amount, but the other is that I implemented a very simple state machine, because if you think about it, when the user goes through this process of chatting with the chatbot, it is going through different stages of the conversation. In a first step, it is introducing the data of the customer, and then the application remains in that state until the customer data are not complete. And in the second step, he has to collect the data on the flight instead, so same thing. And all when these two information are complete, then at that point, it can pass this information to the other Drools instance that is intended to calculate the refund amount. So before I show you the proper demo, I wanted to clarify with the code example how this works. So these are my business rule for refunds for my fictionary airline company. So I'm saying that you are eligible for a refund if you had more than an hour of delay. And then in that case, the amount of the refund is $2 for each minute of delay. And moreover, if you are a senior customer, if you are older than 65, then you can have 10% more of that refund. Okay, so these are the rule of my airlines that I encoded inside the Drools rules. I'm not letting the LLM to invent anything. And just to make this clear, the second rule set that I used for this example is very simple. It's the one that I anticipated. If I don't have a customer, I'm still in this first stage where I'm trying to extract the data of the customer. Otherwise, I will transition in the second state where I will be extracting the data of the flight, and when I will have both, I can calculate the refund. Okay, and the other reason why I'm doing this is also to reduce the possibility of hallucination. Because if you have a very generic chatbot that is prompted with something like you are an airline chatbot, collect all the data necessary for a refund, then it's a quite generic task, and the likelihood of an hallucination is higher. Okay, but if you confine the task that you give to LLM to a very limited scope, then you are reducing a lot the possibility of an hallucination. So what I'm saying is that when I'm in this state, I'm using this AI service that is intended to extract the data of the customer. And when the data of the customer are complete, I can transition to the second state. And at that point, I can use a similar AI service that is intended only to extract the data of the flight. So I'm using LLM with a very specific task. And again, this helps me to also reduce hallucination. So let's give a look of how this works. So what I did is that I created a model, and I could indeed I didn't create the model myself. Actually, I just downloaded the model that I wanted to use from Hacking Face. I put it in an S3 bucket. Then with OpenShift AI, you can deploy your own model, which is in this S3 bucket now, and you can give it a name and choose a runtime and choose the size of the machine that you want to use. Okay, both the server side and the GPU acceleration. Okay, so this is how normally you deploy a model on OpenShift AI. In reality, I did an even simpler thing now, because we have this model as a service environment internally in Red Hat. It's just an instance of OpenShift AI where we deploy some model that we use for experiment and development. So I basically have I registered myself on this model as a service application. It gives me an endpoint that I can use to query this Granite 3 8P model. So the only thing that I had to integrate this is using the Langchain4j extension. Put in here the URL that is given me by the that model as a service application. Here I have the key, and I made some other configuration like lowering the temperature to 0, and I'm done. So that's all is necessary with Langchain4j to integrate any model that implemented the OpenAI API. So what I did is I deployed my application on OpenShift. So I exposed this URL to access it. So let's give it a try. Okay, here I have a few examples that I made to explain the integration between Drools and this other technology. But let's give a try to this airline refund chatbot, so I can start chatting with it. Okay, here of course the very first thing that you can notice is that I totally suck at creating user interfaces. It's not my job, but you can say it from here. But in essence, what's happening here is that I'm starting chatting with this airline chatbot, and if you remember, there are 3 stages of this chat interaction. And the first step is that it is collecting my data as a customer. So basically, it asking for my name and age. Okay, so I can, for instance, say that my name is Mario Fusco. Okay, and what happens now is that I gave it my name, but I didn't provide my age. Okay, so the customer is incomplete. So just to be clear on this, we are using this service. It's trying to produce a customer, but the customer also has an age. I didn't provide my age, so the customer is not still available in the session. And that's why I cannot leave the first stage, the first state of my state machine. It's still asking me for my customer detail, and of course, it's asking. It knows my name. It's asking for my age. Okay, so I can say that 70, for instance, and at this point, all the customer data are completed. So it can transition to the second step. He can ask me now details as my about my flight. So I can say that, for instance, I was on flight 22 and did 4 hours of delay. Okay, now I'm providing also the data about my flight. Of course, in this case, I'm totally trusting what the user is telling me. But so this is a very simple demo. But what you probably will normally do is query a database, your airline database, to check if customer named Mario Fusco was actually on that flight 22, if that flight 22 really had 4 hours of delay. Okay, so of course you can do some sort of validation, and these are also tools that in this case can be backed by your corporate database. But what's happening here is that again, the application now has all the information it needs: my name, my age, and the delay of my flight. So it can transition to the third state when it's actually calculate the refund that I should have. Okay, and not only is calculating this, but as I said, one of the problem of the chatbot is that you don't have transparency. It gives you a result, but you don't know why it produces that result. Okay. In this case, since we integrated it with Drools, now we can use Drools as a tools also to provide an explanation of how this result has been calculated. So I can try to say, explain why I got this amount. Okay, and it's telling me basically now it's simply concatenating the three rules that have been found. Okay, so just to be clear, what's happening is that I'm using this other AI service, which is in the latest used in the latest conversational state when I'm provided already the refund amount, and this service is configured to use this tool when the customer asks for an explanation, and this explanation tool just goes on the session of Drools and collect the title. Internally, it collects the title of the rules that have been filed. Okay, so it is telling me that I'm eligible for a refund because the delay was more than an hour, that the refund amount is $2 per minute of delay. So $2 by 240 minutes is $480. And then the refund is increased by 10% since I'm a senior, I'm older than 65. And then it's 480 plus the 10%. And this is why it is providing this result. Okay, so, and it's telling me why. So I also solved the problem explainability of the result. Okay, so back to the presentation if there isn't any questions. Okay, by the way, if you want to give a look at my code, you can check this repository and play with it. So one of the question is, what if you change the text a bit, which just give me an explanation? Can LLM do the same kind of hallucination? Okay, hopefully no, but I cannot exclude. Yes, there can be hallucination also in this case. I mean, in reality, as I said, my strategy to reduce the possibility of hallucination in this case was giving to the AI service a very limited scope, a very confined task. And this reduces a lot the possibility of hallucination, and it's a strategy that I suggest. In this case, it's quite straightforward for the LLM to figure out that when a user asks for an explanation, it has to call the explanation too. But I mean, I never saw this hallucinating. I had other kind of hallucination in the past, and that's why I'm adding, of course, a screenshot of the possible outcome, because you never know what's going to happen in the with this kind of non-deterministic system. But in reality, for this specific case, I never saw a tool, an hallucination regarding the tool.
Yeah, I mean, overall, of course, it's a bit of a toy problem at this stage. The part of the challenge is that, of course, the user can express the same type of query in many different ways. So in a real world scenario, my suggestion is to, instead of just directly go to the engine, to have a preliminary analysis of the query and try to say, like, given that this chatbot is probably not going to be designed to answer arbitrary type of question, first of all, maybe do an analysis of the question. So again, even use another LLM to say, like, given the 10, 20 different topics that this chatbot is supposed to answer, try to classify is this query apply to one of those categories. So to, for example, do some sort of initial validation to verify if you are asking something that is in the scope of the chatbot. And I can even use that as a feedback to say, let's say that it classify, but I can even try to have like some sort of accuracy type of value to try to understand how sure the model is about the categorization, because I can even connect with traditional predictive AI, use categorization and express the accuracy. So I can use this information to say, like, I think that you're asking about explanation. Can you confirm that this is what you're looking for? So trying to have this kind of feedback loop so that if I'm sure about the query, I just, let's say, go directly and process. While if I don't, I'm not sure that I'm properly guessing the input of the user, I can ask another question. So that is the type of, let's say, pattern that more likely you should try to apply, so that you have a feedback loop that give you always like, okay, I don't trust my user in this way, or I don't trust that my system is powerful enough to always guess that up front. But if you see here at that point, you make the system way more, let's say, it's way easier to customize, because you have a lot of, like, you have the possibility of tool, you have let's say, you can write a service that does even arbitrary validation using some internal policy. So I'm not just trusting the LLM entirely and say, like, okay, the oracle and give me everything that you need to know. It's more like, okay, I have a lot of different extraction points, I have a lot of different techniques that I can apply. Because yes, I mean, of course, if the system only works if you use the keyword that I was expecting, of course, it's
well, yeah, it's the job of the LLM to be flexible on this and to understand what the user is asking and act accordingly, hopefully. Okay, so, and of course this is just an example, so sort of joking, I asked to ChatGPT, give me a few other examples of how I can combine your capabilities with a rule engine. And well, of course, the first it gives me a set of possibilities that are all quite interesting. Of course, the first one is the customer support chatbots that I also implemented in this demo, but there are many of them. For instance, it could be quite interesting to have, I believe, a smart home automation appliance that you can interact with in a human-friendly way, but behaves accordingly with some rules that you configured. Okay, so there are a few of quite a few of possibilities in this field, and to draw some conclusion. The message that I wanted to pass with this presentation is that LLM and in general machine learning is only a fraction of the whole possibility that you have with AI. It's a super exciting technologies, but you can probably complement it with other AI related technologies. And in reality, I believe that symbolic artificial intelligence is a very good complement for this kind of system. I mean, when these LLM things started appearing, they told me, look, we will not need rule engines anymore nowadays. You can do everything with this kind of LLM. And I believe it's quite the opposite. I mean, I believe these are two really complementary technologies. So the rise of this LLM-based system can also increase the need for rule engine and other deterministic but rich tool like a rule engine.
Yeah, and this is I think this is an important thing, because I know you've done rules, etc. here, and that's why you're doing presentation. But even a simple thing as doing a calculation, like just instead of letting the LLM doing it, you just say, hey, if you want to do a calculation, please do it through my tool, which is just purely implemented by code, right? So the general rule here is that it sounds heretic to say, but anything you can remove from an LLM's path of action, the better you're off, right? For being deterministic. But if you do that,
and for cost and efficiency as well.
And efficiency is another thing. Right? But again, that shouldn't make, because you follow that through, go like, oh, just don't use LLM, because then everything is deterministic and you're fine. But yes, but then you won't have the ability to like have what would you call, like a organic flow through some decisions, right? Or some evaluation. So it's this balance of finding things. And so I just want to highlight for people, like, this is not just like applies for business rules. It's for any kind of code, any kind of middleware, any kind of logic you've done before. If an LLM can give you the input to a function, that's way better than letting the LLM execute the function on its own, right? Or emulate it. But then, of course, with rules engine, the power here is you still have all the good old features of a rules engine, that they can be updated, and you can encode rules that can be flexible, but within like specific rules. But letting the LLM extract the information, like the input, and then hand over is a perfect thing. And I think that applies to anything out there. So yeah.
It also simplifies a lot, even like the adoption of similar technology, because more likely you already have existing software that has been validated that does exactly the type of business logic that you need, rule-based or like code-based or even whatever way. And you can easily plug and compose and say like, hey, I want to make the interface easier, or I want to make that more flexible. So I want to leverage this tool that is, let's say, very flexible. So if you think about even like code analyzer, the flexibility that similar tool has to really understand like the meaning of code, it's way stronger compared to what you can easily do with a traditional static analyzer tool. But at the same time, it's also true the other way around. I mean, if I needed to verify a formal syntax of my function using this kind of copilot type of technology, if I have a grammar that I can just apply and say, like, this is how my function needed to be from a formal perspective, need to be written, why don't I can use that and just mix? So yeah, I mean, here in this part of the conclusion is really like LLM is yet another powerful tool in your toolbox. It's really mind-blowing in terms of how powerful it is. At the same time, you need, like any other tool, you need to know when to use it and when it's not. As the general guidance, don't use that as a knowledge base to extract factual information, because that it's the worst case scenario in terms of hallucination. Try to be very specific in the context about what you are looking for. So provide the model really context that can use it to be very efficient and very effective to understand which tool to use, which step need to be executed. And then, well, agentic AI, it's a bit more like the generalization of that, to say like, this is becoming a pattern that you use to actually build let's say, an AI-based application where you still mix the core knowledge that you already have, maybe you already have written 20 years ago, and then it's still there because exactly solve the problem that you have, and you just make that more flexible. So that is like the real gist of the presentation.
Yes, and I second what Max was saying. I mean, my very bottom line is never use a probabilistic an LLM or similar thing to something that has a clear algorithmic solution. It's a waste. It's more error prone. It's a waste of energy, as Oli was saying. There's no reason to do this. I mean, these things are amazing and super useful when there is something that doesn't have a clear algorithmic solution. If there is one, they are a waste.
100%. Yeah. Cool.
That's probably a good point to wrap up. I think we've got through all the questions.
Awesome.
So thank you very much, Mario. Thank you very much, Daniele. Really, really interesting, and hopefully it's given lots of people some food for thought.
Thank you for having us.
Have a good rest of week, everybody.
Bye.
See you all.
Thank you.